You're welcome to online lectures with From a Time the Schoolboy. I want to welcome you back from a brief break. The last lecture we had was the calculations in chemistry for those that join us for the first time. So we want to go into calculations in physics. That's why I'm playing this now. So go over to calculations in physics. I'm just playing this chemistry. Go over to calculations in physics. Okay. Excuse me. Calculations in physics. We have a question here. The question says, this marker is not writing well. Okay. Okay, the question says, a flask full of methane takes 90 seconds to effuse, while the same volume of gas X takes 149 seconds. What is the relative molecular mass of gas X? What is the relative molecular mass of gas X? This question is taken from the question source is Basic Sciences for Nursing and Midwifery, 3rd edition by Obanishola Olubenga Dele. Question is taken from page 11, exercise 1, page 11. So let's use this as our topic for physics calculations in physics today. This has to do with rate of diffusion in gas. I'm comparing the rate of diffusion of two gases, methane and gas X. And also serve as a link to determine the relative molecular mass of the gas, of the unknown gas. So that's what this question is all about. And the law that explains this is the Graham's law of diffusion. At normal atmospheric conditions, actually, Graham's is trying to let us know that the rate of diffusion is inversely proportional to the square root of the what? The molecular mass of the gas. That's what Graham's law wants to let us know. The rate of diffusion is inversely proportional to the square root of the what? The relative molecular mass of the gas. So that means as the larger the relative molecular mass of a gas, the rate of diffusion will be what? Lower. But by square root. So that means if you have, okay, let me not talk too much. Let's go down to business. Let me not talk too much. Let's go down to business. Actually, Graham's law solution. Actually, Graham's law is trying to let us know that rate of diffusion is inversely proportional to the what? Square root of what? Relative what? Molecular mass of the what? Gas. That's what Graham's law is trying to let us know. So that means there should be a constant. If you now make it a constant, that means R is equal to what? K over what? Square root of what? Rm. Okay, let's use M. So let's just use M as relative molecular mass so it doesn't confuse us with this R, with rates. Let's use M. So this implies that K is now equal to what? R what? Square root of M. That's the meaning. So basically we now have that that R1 M1 is equal to what? R2 M2. That is, this happens from one state, whether one case, one gas to another gas. You are comparing two gases now. R1 for the first gas, square to relative molecular mass for that first gas will give you the rate of diffusion of the second gas times the relative molecular mass of that what? Second gas. That's what this law is trying to let us know. So that means R1 over R2 is equal to square root of M1 over what? Square root of M2 over what? Square root of M1. But here now, what we have here is two gases, and the two gases involved are what and what? Are methane and gas X. We don't know the name of gas X, but we are told to find the relative molecular mass of gas X. So if you want to do that, that means let us now substitute them with these values we have here. Remember that rate, with respect to this now, the volume that they fused, the rate, as in with respect to the time taken to be a fuse, the rate is simply the volume over what? The time. Rate is volume over what? Time. Now here, they have the same volume. So V is constant for two of them. They have the same volume. So if they have the same volume, we have something like this. Remember that rates R1 is equal to V1 over T1. Because V1 is the volume of the first gas, which is methane. T1 is the time taking, it takes the gas, which is methane, to a fuse. Now, while R2 is equal to V2 over what? T2. This implies that R1 over R2 is now equal to what? V1 over T1 divided by what? V2 over what? T2, which is certain as saying V1 over T1 times V2 times T2 over what? V2. But V2, 1 is equal to V2. So they will cancel. So we now have that R1 over R2 is now equal to what? T2 over what? T1. T2 over T1. This cancel because they are equal. Constant volume. So R1 over R2 is equal to T1 over T2. So whenever we see R1 over R2 in this formula, we'll put T2 over what? T1. So we now have T2 over T1 is now equal to what? Square to relative molecular mass of M, the first gas, over that of what? The second gas over that of the what? The first gas. This one represents what? Methane. While 2 represent what? X. So we know the relative molecular mass of methane. Simply add carbon plus hydrogen is 1, carbon is 12. So hydrogen is 1, hydrogen is 1, carbon is 12. So this one is now 12 plus 4 times 1, which is what? 4 times 1 is 4 plus 2, 16. So the relative molecular mass of methane is 16. So we know methane M1 to 16. The time for methane is what? We want to substitute. Time for methane is 90 seconds. So T1 is 90 seconds. Time for the gas X is 149. So T2 is 149. But we don't know square root of what? M1. We don't know the relative molecular mass of what? Gas X. So we now substitute. So T2 is what? From the you see is 149 there. 149 over this is not writing well again. 149 over T1 is 90 seconds, which is equal to M2 is square root of 16 over square root of what? M1. So using law of indices, this is certain as saying, using law of indices, this is the certain as saying, I think I'll clean here now. This is certain as saying root 16 over root M1 is certain as saying root 6 everything over what? M1. That's the meaning. So if that is that, so we can say that 149 over 90 is equal to what? Is equal to what? Or we may not even go there, but let's just see. It is equal to what? 16 over what? M1. That's the meaning. Also, moving this thing to this side, it will square this side. So we have that 16 over M1 is now equal to what? Square of 149 over 90 all squared. 149 over 90 all squared. Over 90 all squared. So M1 is now simply what? 149 over 90 all squared divided by what? 16. Because if you divide both sides, no, what am I doing? Let's expand this first. This certain as saying 149 squared over 90 what? Squared. So that means 16 over M1 is equal to 149. That is not exactly well. 149 squared over what? 90 squared. So M1 is equal to what? We can multiply 16 times 90 squared all over what? 149 squared. So anything we are going to do here now is we simply multiply and cancel that and get the answer. So M1 is now equal to 16 times 90 times 90 divided by 149 divided by 149. 5.84 seconds. 5.84. Sorry. 5.84. The relative molecular mass of this is 5.84. Is it 5.84? Let's revisit this thing again. We have this. We have this. Oh, error. And there's an error here. This should be, this is M2. This is M2. And our 2 here is gas X. So this should be X. This should be X. We don't know this. Okay, this is M2. This one should be 16. Sorry. M1 is methane. See, here should be 16. Here should be 16. It cannot be 5.84. Please, there's an error here. It cannot be 5.84. So this is 149 over 90. This should be, this is root 16. Because M1 is X. M1 is methane. So here should be 16. While M2 is gas X. So here should be gas S. This M2 belongs to gas S. So we have 149 over 90 is equal to square root of relative molecular mass of gas S over what? I think I should put this so I will not confuse myself. Yes, I think it's better this way. So we can easily solve this now. I think here is simply 4. So we have 149 over what? 90 is equal to square root of M subscript X over what? 4. Good. So if you multiply, square root of M subscript X is equal to what? 149 times 4 over 90. Correct. So we have to square both sides to get X. So if you square both sides, we have Mx is now equal to what? As we have to square everything, here 149 times 4 over 90 all squared. So if we now calculate this, we have 149 times 4 divided by 90. Times 6.6222222 for 3.85. Correct. So is what? 43.85. Approximately 43.9. So the relative molecular mass of gas X is 43.9. Sorry, I made a mistake. I came here instead of using M2 for gas X, I use M2 for methane. So that's where the error. That was where I got 5 point something. So I've gotten the correct answer. Thank you very much for your attention. The answer is what? for 3.9. So if you have a question, please feel free to ask. If you have a question, please feel free to ask. You can call any of the numbers on the screen on the board, 08138682003 or 07012945891. Call any of these numbers and I will attend to you. So we have 2 minutes to go. We have 2 minutes. Call and ask your question and I will attend to you. Ask your question. Our time has elapsed. In absence of any question, we end this lecture here. Please feel free to chat me up on any of these lines for if you have any question. Thank you very much for your attention. God bless you. At exactly 4:30, we'll come back again for mathematics. See you there.